Hi there, everybody. How many of you? What's up? Is everything okay? Let me enable the chat once again. For some reason is disabled by default. And I never remember how to do that. Just give me 1 second. And everyone, okay. So it should work for everyone. Let me know if it works. Great. So as usual, we are going to wait some minutes to allow everybody to join. So we are 53, quite a bunch of people. 54, wow, great. So let's wait a little bit more, at least 5 minutes. So in this webinar, I'll try to cover the gain staging part of mixing, which is the very first part. And honestly, it should be taken also care during recording if you do record live stuff. So, but I'll keep the explanation for where the webinar starts. So this webinar will last, I think, for about 1 hour. If we have enough things to say, and even more if things get interesting, sometimes that happens, but I don't know if this time it will last that long. And of course, it will be recorded, and the streaming will be available on YouTube in the next days. So if you lost something or you want to go deeper with something that you haven't heard because you were busy or something else, you will be able to watch it again once we go on YouTube. Yes, every webinar we made, every recording is available on YouTube, also for the previous webinars. Tony D asks the first question, am I correct in thinking there is no way to repair a recorded vocal track that suffers from clipping? Well, there are some tools, we don't have any in our collection, but there are some tools that tries to recover a clipped audio. But anyway, it's better to not clip in the first place. Honestly, now out of my mind, I can tell you any of these tools because I never use them and I don't remember, but I think a quick Google search can return something. Restore clipped audio. Let's see if we can get something. There is something from Isotope, it seems. It's called the clip. You may want to have a look to that. And quite a bunch of articles on the net, so you can just do a Google search and you may find something useful. So what's the time right now? 7 and 5 minutes, so we can start. How many people in the house? 65. Wow, I think this is the record. We've never been that so many. So hello, everyone. Hello to the usuals there. I see a lot of faces, a lot of names that are already seen many times. And I think we also have some new person. That's great. That's great. Ok, so. Ciao Claudio, ciao, dal Livorno. Siamo vicini alla fine. Io sono a Colle Valdelsa adesso. By the way, let's start and let's dig into this topic. And let's say that gain staging, it's something that belongs to the analog part of the audio recording, because nowadays with digital workstation that we have, the bit depth that we have is not that important anymore, unless you are planning to use analog emulations in your mix. That brings you back to the analog world. So let's say that the gain staging part is where you set the input levels of your virtual desk, your desk, to allow for the proper input levels. Because if you are running too high into the audio channel, I'm talking about analog world. If you were running too hot, if you are reaching with the input level with a voltage that is too high for it to be handled, you're going to get distortion. And sometimes it's what you want, but for the proper technical parts, you don't want any distortion. That's the reason why we invented the digital processing, because we wanted to avoid the nonlinearities, noises, distortion that came with analog and all those limitations. So you have to make sure that your signal is not too high to avoid distortion, and it's not too low, because every analog gear has a noise floor. And if you set your signals too low, you are going too far to the minimum allowed level by your analog gear, which is its noise floor, that it's much higher than the one of any analog to digital converter. So if you run your audio through a vintage compressor, for example, which has a noise floor of -70 dB, that's not unusual, that's pretty usual. So you have to make sure that the lowest passages of your audio does not fall too close to that level, or even below. The tails of the reverbs or anything else. So Chris Rizzo, you say that gain staging happens at all levels in the mix, input level of instruments. Yes, right. Volume of clips before the hit plugin chain. Yes, partly right. After each plugin, change the perceived volume. Almost right. The graph buses and master buses. Yes, but given one condition, that sorry, two conditions. The first one, you are working with an analog console. So you have to keep your levels right. You're walking into the digital world, but you are using analog emulations. In that case, you have to pay attention to the level that you feed your emulation with. Oh, sorry, I forgot to put offline the phone, and I don't want anybody to disturb us. But anyway, let's get back to where we were, talking about the input in the analog world. So when you hit the preamplifier, you have a trim pot, gain trim pot, that allows you to hit the preamplifier of your channel strip with the right amount of current, because we are talking about voltage and current in the analog world. These, I'm telling you this because everything translates perfectly into the digital world when using analog emulations. So you want to hit your inputs at the right level, and the right level has been standardized a long time ago, and it's around 0 VU when we talk about VU meters. Old consoles and today's consoles too, I have mixed recently a couple of days ago on an SSL duality that has analog VU meters on the master and as input channels, because it's very useful to know, to watch at the needle moving to set the right input. Just let me explain and then I'll answer all the questions. You have to hit your preamp at the right spot. There are some kind of sound that you want to be hotter because you like the distortion that you get from the preamp. And from that point on, you're gonna keep your loudness as steady as possible, because in this way you can monitor with the correct loudness, not being full, but loudness increased. And you are feeding each of the stages of the chain with the right voltages. So that's the reason why analog gears as input and output knobs, and this has been added to digital gear too. So now we enter the digital world. Assuming that the sounds you are working with are being generated inside the computer or are being perfectly recorded by someone else or you, until you touch any nonlinear processing like analog emulations, you don't have to care about gain staging. That sounds weird, but that's the way it is. Inside the digital world, you, of course, I'm talking about today's digital world where you have floating point mixing engines. You cannot overflow the mixing engine and you cannot get any digital clipping. So if you have a soft synth and you create your perfect sound, you can use all the digital tools you want, given that they are not emulating anything, they are pure digital processors. You don't have to care about gain staging. You may also keep all your channels into the red, and you are not going to hear any kind of distortion, unless, of course, you are clipping your master bus. In that case, you are going to feed the analog part of your chain, which drives your speakers, too hot, and this is going to this is going to distort the signal. But inside the digital processing part, you cannot get clipping because we are using today's floating point numbers. That means that when you increase the value with a fader, you are actually multiplying one number with another. And if you have the decimal point floating, it means that if the number gets big, the decimal part gets smaller, and you can keep on increasing the numbers. And if you are using smaller signals, the point move left, so you have a lower integer part and a bigger decimal one. So there is no way to clip the mix bus. And there is no way to feed a digital plugin, like, for example, our Total EQ with all the analog emulation turned off. You cannot feed it with a too hot signal, and you cannot get a too hot signal out of that, because inside it uses a floating point arithmetics. So there is an infinite headroom. So this is the first thing that you have to know. This stuff only matters when you use analog emulations or when you are recording your tracks. I mean, if you do live recordings of a vocal, of a drum, of a guitar, bass, whatever, you have to keep your levels right. So, because you are hitting the analog front end of your sound card before hitting the digital realm. So you get your levels right on the front end, and then you are safe to go inside the digital realm. the first the first version of our VU meter that now is some years old, didn't have any sort of auto gain. It was just a digital VU meter, and it was useful nevertheless during recording, because every DAW in the market comes with digital peak meters. Many DAWs now allows you to change the kind of meters you have, and in which with a more useful meter, because digital peak meters are almost useless. They only serve you to know the digital levels of your tracks, but this tells you nothing unless you know how everything works. A VU meter is much more useful because it measures the loudness of your signal, not the peaks. So when you record a vocal performance, for example, you know that you have to keep your VU meter at around the 0 VU to use the analog part of your sound card at its best, because every analog front end of every sound card has a sweet spot that is placed by the manufacturer at around 0 VU. And the 0 VU is calibrated to a certain dBFS point. Usually, it's a given standard, it's -18, but it may be something completely different. For example, some small sound cards that are USB powered has a much lower headroom, because the headroom in a sound card is given by how much power the sound card has inside to handle the analog sound between the maximum and the lowest possible peaks. So if you have 5 volts, of voltage to give your sound card power, you cannot handle more than 2.5 volts above 0 and 2.5 volts below 0. Consider that a 0 VU signal is, in the professional word, 0.7 for the positive peak and -0.7 volts for the negative parts. So you don't have that much headroom at all. So find out, reach for the specs of your sound card. Professional sound cards like the Prism, Lynx, Apogee, they use a higher headroom, and they can go up above to 21 dBs of headroom. So in that case, when you use the VU meter, you have to set your 0 to -21. So you have to know the specs. But if you use the defaults in our VU meter, you're going to be pretty safe. So I don't have anything to record right now except the microphone I'm talking to, because I'm in the office, but I can't give you any demonstration of that. But I can give you a demonstration on how to use these tools when you are already inside the box. So I hope your recordings are done right. I'll share my desktop, and I have a track which is completely raw. I only have bass and drums recorded, so it's a perfect target for this example. Okay, share screen. I share the desktop. And then I want to enable the computer sound and the stereo high quality mode. So here we are in our Reaper session, and I'll only solo the drums. So you can tell me if you hear anything. Is it working? Are you hearing? Perfect, perfect. Is the level right? Can you hear? Can you hear me when I talk? These drums have been already recorded using the technique above. So, okay, maybe it's too loud. Let me turn off. So if I play now, can you hear me? Like this. Hear me? Great. Okay, that's great. So we are not going, it's not important to hear how it sounds, but we have to look at the numbers and see what happens. So if, for example, I fire up the VU meter, this is the latest version of our VU meter, it's the MQ4. I usually use this tool when recording and monitoring, and I prefer to use the normalizer when preparing the session, but I show you both anyway. This is the reference I was talking about before, and is where you set your zero. That means exactly means that when a steady signal made with a sine wave at 1 kilohertz hits the VU meter, the needle is gonna read 0. Of course, the signal has to be at negative 18 dB full scale. So if I change this, the 0 point changes. Consider that when you reach 0 VU, you are actually clipping your converters in input. So you don't want to reach that. That's the reason why you place your 0 to negative 18. So you have 18 dBs of headroom if you get any peak that is out of control. And so you can have the room to breathe. I don't know if I explain myself. If I place my 0 at negative dB and I'm aiming for my 0, I can handle higher peaks without problems. Keep in mind that this kind of meter does not represent short peaks. It only represents the average level of the signal. That's what you want. Your ear does not care about peaks or short transients. The ear only listens to loudness. Short transients, like the one in the kick drum or in the snare, are felt, if you are in the room with the instrument, are felt more physically by your chest. So if you don't have big speakers that can move enough air to let your body feel the transient, it's better to let the brain imagine the transient and focus on the loudness. Okay, Graham, if you have any question, when you leave, Graham has to leave. If you have any question, just comment, feel free to comment on the YouTube video and I'll try to answer. Then, again, a VU meter or a loudness meter of any other kind, it's more useful in mixing any recording because, again, you want to focus on the loudness of your signal, not the short peaks. And the digital meters you have in your DAW represent only the peaks. Okay? So if you look at the kick in, now focus on this track, look at the difference on what the meter shows, the VU meter shows, with your peak meter over here. It's completely different levels, and the peak meter moves much faster. The VU meter is lower because it's only focused on the loudness of the signal. Now, modern DAW, like Reaper, many other, Reaper and Pro Tools comes to mind, can use different kind of meters from the menu. You can choose LUFS momentary, for example, that is much more useful. So if I now look at the meter, see similar values, because this is reading negative 28 and we are putting our 0 at negative 18. and this is reading -10. So we are reading -20 degrees as well. Are you following? Because this is a little bit more complicated, let's say. I keep the peak meter nevertheless because they use much less CPU. And if you use LUFS meters all over your session, you are sacrificing a lot of CPU for the meters, and you can use much less plugins, of course. So this is something you have to balance. That's the reason why peak meters are the default for every channel in every DAW, because that's the kind of meter that use the less amount of CPU. So I want to bring this sound at around 0 VU, because I want to do this, because this is the level, the desirable level for me to process the signal with analog gear. May it be external analog gear or emulation inside the DAW. Whole show. I have to struggle with CPU all the time. My solution is to disable all of the analysis plugins. Yes, this is the solution. A good analysis plugin like the VU Meter does not use any CPU when it's closed, because all the processing is done when the interface is open, because it's done in the interface thread and not in the audio thread. But to disable that saves even more CPU. Now we are using with the interface open 0.5% of this i7, and it's very small usage, but it's something. So if you disable the plugin, you are freeing also this amount of CPU. So let me get back to the process of gain staging. A tool like this has a gain knob hidden here, so I can use it gain stage and track manually. But this is a waste of time. For this reason, we have provided the auto function. So I'll bring it back to 0. And the auto function is even more useful if you use it with many tracks at once. So let me copy the VU Meter on all our drum tracks. So I open one of them. I say that I want to send to all the auto function, and it becomes orange, this dot. Then I want to say that I want my 0 VU to -18. That's fine. This is a protection, because since a VU meter is a loudness meter, peaks may well be over the digital 0 if you are not careful. Because short peaks like the one in the snare or the kick may be really too short for the VU meter to consider, and the loudness is so low that it has to give a lot of gain to bring the signal to your desired target. This may bring the peaks well over the 0. So this is a kind of protection that it's on by default, and it is put to a safe level of -6 dB. Now, shockingly enough, we are not going to use that, because we want the peaks to be higher than the 0, because we want to use analog gear afterwards, and we want to hit this analog gear with a very high level to shave off these peaks and get more loudness out of a signal that does not has it as starting from. So the famous tape saturation does exactly this. It shaves off the short peaks while you're recording onto tape. I mean, while recording to real tape, it allows you to shave off the peaks to get a higher level onto the tape. So we emulate tape for this reason. So what we're going to do now is to turn this off, set the target to 0, and let's say I want to send to all also this. So I turn it off, and every instance has it off now, as you can see. Yeah, sorry. Paul show VU meters aware of their meters. Yes, you have 8 groups that you can use. So you can group instances for different tasks. I tend to group drums together and everything else. But for this demonstration, I'm only using drums, so grouping is not needed. You can also change the name of your group. So I can do something like this, drums, and then in every other instance, I have drums and not group 1 anymore. But this is not important right now for the gain staging. I have a video explaining how the VU Meter MK4 works. So if you want to see a demo of the plugin, you can go there. But what I want to do is to bring all the tracks to 0 VU as fast as I can right now. I'm lowering the master volume because we are going to bring the tracks up in volume. Okay, here we are. Radznav Krivac, am I right? The maximum is functioning as a limiter or doesn't allow the loudness to reach -18 if it tracks big. Yes, the second one. It's a ceiling to the normalizing process that only looks to the peak in dB. So if bringing up the volume to reach the loudness target that we want causes the peaks to be higher than the maximum level, the normalization process is stopped. So you only get as much loudness as you can before hitting that maximum peak with any sample in the track. So I turn it off for this reason, because I want to show you first that we are hardly clipping many of the tracks. You see, we have the snare up, snare down, the overheads are clipping, but listen carefully. Can you hear any distortion? You can't, because we are keeping everything in the digital realm right now. So we don't have any sort of clipping. We don't have any distortion because we are all digital at the moment. Now, I'm going to put our tape emulation on every track and see what happens. Okay. Now, these 2 tracks are going to clip. You see, you don't have reds anymore. What happened? We have the tape emulation taking care of the peaks. The VU meter on tape are telling us that we are clipping, but since tape gently clips, we are actually shaving out the short transient and getting more loudness out of our track. So if, for example, I add a loudness meter on the master, like our ELM, let's see the loudness we are getting without tape. Just let me figure out how to get to the menu, which I have Zoom in front of it and I cannot. Okay. Let me do it manually. Or maybe I remember the shortcut. Yes. So I will simply bypass all the tape instances. So tape is off. Let me see the loudness we are getting right now. So with all the tracks clipping, we are getting -12 integrated LUFS. And if I reset this thing and I add tape back, let's see what we get. It's a little bit lower, but we are not clipping anymore. Not at least, okay. This is allowing us to use a compressor more easily. So if I add whatever I wrote, where is our butterfly plugin? Okay, I will add another compressor. I will add, for example, the SIG compressor. Do I have it? No, for some reason I cannot find some of our plugin. I don't know why. Let's use our LA2A. Okay. So if I disable once again tape, I don't know if this is a good example, but because the meter on the LA2A moves slow, but should work more. Let me see. Now it's disabled and the meter should work quite fast. So at least go down below here because we have peaks. Let's do DDP production to now if I bring tape back, see, with the same amount of compression, the needle moves much less. This is because we have reduced the amount of peaks. This gives us two benefits. First one, we can make a compressor work less for the same amount of loudness. Or we can get more compression without pumping. So this is up to you. But the fact that we are hitting our analog gear with a higher signal, with the correct signal, allows the analog gear to remove the short peaks that are found in the digital recording and allow us to get more loudness out of the recording. Is that clear? William asked if my interface specification says that 12 dBu is 0 dBFS. Can I take the information from that 0 VU? Yes, your 0 VU is -12 dBFS. That's it. dBu, what they say dBu is actually way to measure loud levels that is typical for the analog gear. And a 0 dBu is actually 1.44 volts peak. That means 0.7 above 0 and 0.7 below 0. So this is 1 dBu. So if you have 12 dBu, it means that you have 1.444 multiplied by 12 headroom in voltage. So if you place your 0 VU at that point, you know that when you are hitting, the VU meter reads 0, it means that inside your sound card on the converter's input, you are getting the nominal 0 dBu voltage. And this may work, this may make your analog front end work at its best. So this is why gain staging is important, because you want to get loudness out of your tracks and not peaks. Peaks are not important. You don't want them. You only care about loudness when you're recording. We can do the same thing with another plugin that it's called, let me remove the VU meter. It's called the normalizer. I can remove the VU meter here. Where is I replace that? No. Remove from projects. So I don't have that anymore. And I can add the normalizer. Keep in mind that our plugin tape has the same algorithm built in, the same VU meter. So in this case, when using this plugin, gain staging plugin like the one I showed you, the VU meter, is not necessary, because I can do this and it's going to do exactly the same thing by itself, compensating the output of the same amount to keep the loudness steady. So this is just as a side note. But when I'm going to do this, I'm going to show you the normalizer. This plugin does exactly the same thing and much more. Fire it up, because we can use a more modern way to measure loudness. So you can use dBFS if you want to normalize to a certain peak level. This is mainly useful on the master bus to make sure that your master doesn't exceed the certain dBFS level. VU, you cannot change the reference in the normalizer. It's -18 by default, and you cannot change that. RMS, the RMS window is 600 milliseconds. RMS is a mathematical way to express loudness, and it's more technical than linked to any real aspect of hearing, because it just takes the level of the signal and creates a mathematical average. So it's not really helpful unless you have to respect some specific specification for your master for the output. So LUFS is much more useful because it takes into consideration how we perceive different frequencies. It has an input filter that allows the signal to be shaped and to concentrate on the frequencies that the human ear is more sensible to. And we have three different readings. We have the momentary, which takes a window of 400 milliseconds, and it's very similar to the VU meter. We have the integrated one that consider the input signal from the beginning to the end. And this is very useful to get the overall average of a program. So it's useful on the master, not that useful on single tracks. And you have the UFS short that takes only 3 seconds of time for signal, This is not that useful in audio mixing. It's more useful in audio broadcast to make sure that commercial aren't too loud. But this is just here because you may use this plugin in broadcast too. Why not? So for the mixing and for our mixing preparation, our gain staging, we're going to use LUFS momentary because it's more useful. And I'm going to target -23, which is the standard that EBU, the European Broadcasting Union, recommends for audio material. Now, you'll find out that this is going to sound louder than you want, but let me put it to every track. This plugin has grouping function to made mistake. I also made a mistake, which I want to add this to every group because this does not has a send to all properties feature. So move it back, the normalizer over here, the normalizer over here, over here, over here, and we got the last two, one here and one here. Now we are ready to process everything. So if I set -23, you see that it's a little bit higher than what we want. Press analyze. Bypass this one. This does not have any kind of protection like the VU meter has. So we are just normalizing to these levels that we required. And you see we get similar results to the VU meter 1. And same, now tape is working like before. I can go even higher, maybe to -18, like the VU meter. Press analyze, let everything. You see, we are reaching a little higher. We're reaching one on the VU meter. Okay. So we have normalized our track. We're getting some gain over here. This works exactly the same, but we are using LUFS. Now, it's better to use LUFS or VU meter. It depends on what you're used to. I'm used to measuring using a VU meter, so I prefer using a VU meter. But with an LUFS meter like this, and a normalizer like this, you can also, oh, sorry, Darko asked, until now I've mostly done gain staging with a normalizer and then as a VU meter. Notice there is a difference of 3 dB. Yeah, when I put it on the mono track and on the stereo track during mix. That is mean that during a staging should be calibrated differently. Oh, well, it's different because when you use the normalizer, it uses the EBU standard that asks us to sum all the channels together. So if you put it on a stereo channel, there is a compensation for the gain you are getting when summing two channels that plays almost the same thing. So you would get a higher level. For this reason, there is a compensation inside the plugin. While the normalizer only looks, no, sorry, while the VU meter only looks to the highest of the two channels. So if you have a channel that peaks higher than the other, that's the one used for normalizing a VU meter. Tony asked if it's a good idea to run your final master through the normalizer to set the level for streaming platform. That may be a good idea. I don't do this. I do it by hand. I look at the meter with the LEM 128 or the meters in the butterfly. That's what I use to prepare my final masters, and I'm used like that because I always have the plugin open and I can have a look quickly to the meters, so I can adjust the compressor, limiter, and clipper to get the level I want on the fly. Because if I do this with the normalizer, I can get maybe higher peaks or lower level, because if I ask it to normalize to say -10 LUFS integrated, and I have peaks going over 0, then I have a problem. I don't have any kind of protection or any kind of limiting. I could do this before hitting the limiter, but then I don't have any control on how much limiting happens. I have to change it afterwards, and then it also changes the loudness of the signal, because if I reduce the distance between peaks and the lower parts, I change the overall loudness. So I prefer to do it by hand. Well, no, it doesn't take any kind of pan lows, because it sums the two channels together, and it lowers the level by 3 dB to make room for summing. Okay, that's how it should be done according to the specs. Doesn't have to be the same as the VU meter, but it's like this, what the specs say. So it's just like this. Paul, it's the loudness of a single track normalizes to negative LUFS. Yes, every single track is normalized to -18 LUFS. So if I go to this other track, for example, I get a different gain, because that's what it takes. It's in input, it's a -25. So if I want it to be -18, I have to add this kind of this amount of gain. Paul, you're welcome to look at the recording when you want. So bye, Paul. That has to go. And what more to say? As I was telling you, gain staging, it's important only if I repeat that because this is the crucial part. It's important only if you are hitting analog emulations or real analog hardware. Lovis, what I mean is you gain with the limiter at the end, then you don't need to run any normalization up to. No, the limiter is always the last processor in the chain, in the master chain. Well, the last processor is a loudness meter in my case, because I want to know the loudness at which I am after the limiter. But if I normalize with something like that to a certain level of loudness and then add a limiter after that, I get a different level of loudness after the limiter, because the limiter is going to work on the peaks and change the ratio between peaks and lowest part. So it changes the loudness, increasing that. Then, since VU meter says -18 in the normalizer of the music, yes, exactly. The VU meter, the VU metering in the normalizer is calibrated to -18 dBFS. Then, Ricardo, in single tracks, you suggest to set to 0 VU. Most of them, yes, 0 VU, because you have most part of the tracks are more body than transients. If you have drums or percussive stuff or a synth that has a very short sound, then you can go higher because your ear is not going to feel any distortion if you push it higher. I mean, if you push the analog emulation afterwards higher, and you are going to get more loudness from the track than you would if you were sticking to 0 VU. For example, I love to run my drums not at 0 VU, but as at 3 VU. And in this case, we are talking at a UFS. I could have put here 15 as a target, because let's say that negative 18 is my 0, and I want to go 3 dB higher. I can go to negative 15, and I can push the tape emulation much hotter without getting any nasty distortion. See, I'm not getting clipped because the tape emulation is shaving off the peaks. And if I look at the level I get, it is slamming. It is completely slamming. But listen carefully. Don't get not getting any nasty distortion from the tape emulation. You can clearly hear the difference. If I turn it off, we have the same level bypass with the same levels. Okay, I put it down here at -6 and I'll turn it on and off. Off. You're barely hearing any distortion, and you're getting more body, more loudness from the tracks, because since we are shaving the peaks, we can now have our compressor work less, work better, and increase the loudness. Tony, it sounds like it would be easier to go full digital, but probably wouldn't sound as good. Well, no, you can go full digital, for sure. You have to know what to do. If, for example, you are not getting enough loudness for your track from your tracks, you're probably having too many peaks in that. Your compressor, your limiter are working too much on the peaks. So the first thing you should do is put a limiter, digital limiter, like our Magnus, or a stock limiter you have in your DAW from our competitor Waves, for example. The ALTU limiter is perfect. You put the limiter first, you shave your peaks, just those 3-5 dBs, and then you work like you are working in an analog way. That's what analog stuff does. It instead, look at my hands. I'm going to do the Italian now and use my hands a lot. If this is the transfer function of a digital gear, which is linear, it's a perfect oblique line at 45 degrees between input and output. Analog gears does this kind of things. It's linear until you reach a certain point, then the current cannot flow anymore inside the transistors, inside the tubes, and it starts shaving off with a gentle knee until you reach the level of the power rail of the analog gear, and you cannot go any higher. So it has a gentle knee until that level. So when you push it hard, you hear distortion. But if you push it gently, you are just shaving the short peaks and you're getting more loudness out of it. Let me run through your questions because they are quite a lot. Does it make sense to use a setting volume to pursue to drive later? Yeah, Chris, it may make sense to use the VU for the percussive stuff and the UFS for the melodic parts. Yes, why not? I tend to use every VU for everything, but why not? Okay, you set negative dBFS or track for your mix. Oh, inside your mix, keep in mind that when I was talking about the reference for your sound card, I was talking about the recording part of tracking. If you work with digital analog emulations, it's a given fact that the 0 VU it's -18. Almost everybody does this. So do not change it. You are going to run everything too hot if you set it to -12. Interface has different debus for different inputs, different instruments. How do this translate to the if? Okay, so you have to look at the spec of your interface. In the spec, if it's a professional interface, you're gonna find the spec of its headroom. There is not a rule, but if it says that max input is 9 dBu, it means that you have 9 dBu of headroom. So when you put your 0, you have to put at -9 so that you are not heating your interface too hot. Instrument max input is 12 dBu. That's it. If you're recording an instrument, you have to use -12 for the headroom. By the way, sometimes the normalization sometimes doesn't seem to cope with one of the other tracks and the volume is very high for a moment. Yes, because it happens in real time. So as soon as it finds the higher peaks, it turns out the level. So it happens like this. If the track is quiet and then it suddenly starts to play very loud, it takes a little while to go down. It's not instantaneous. So Chris, could we start by normalizing all the tracks clips, say to -5 dBs, and then start is a chain on the normalizer? Well, I think it's not necessary, honestly. You can safely say, keep in mind that you have to plan ahead. So if you want to mix using analog emulations, you really don't care about this, about the highest dBFS level you are using. So just decide that your loudness, required loudness is -15 LUFS, for example, -18, -23, and go with that. Analog stuff is going to shave off the peaks, and if you have problems, you hear it because it starts distorting. Okay, let me see if there are some interesting questions. Plugs and calibrated. So the difference between track utility and VU Meter. Well, track utility from our plugins is another beast. Let me open the last version. It has peaks and RMS level, doesn't have a VU. It's more of a technical side. And then you have other tools that are handy, like a DC filter, the mute button, the ability to work on left or right or swap the channels, the phase reversals, auto gain in peak mode or RMS mode, because it was meant more for a technical point of view. And you have the pan, and you have the width of the track. This actually works on mid and side, changing the relationship between the level of the mid and the side part of signal. And also you can group everything. You see a lot of groups over here. And we have the adjustable RMS window. It's more of a technical plugin. You also have a clipper and a limiter with the fixed threshold of 0 dBFS. This is just for protection, and you can change the release the time. This goes accordingly to the tempo of your project. So So everyone is saying goodbye, it seems. In Measure, is RMS helpful in any way? Okay, RMS is helpful when you have to respect some specification, or if you're used to that. For example, something like 15, 18 years ago, when I was mastering, I was looking to RMS because LUFS has not been invented yet. And I was looking for commercial level masters that run at around -10, -8, or something like that RMS. So I was using RMS to measure loudness. Nowadays, I use LUFS because it's a more precise way, but why not keeping RMS? Many specs are written according to RMS, so why not keeping that? So we don't run into many questions. Can you give a short summary of what to do for gain staging? Yeah, sure. Gain staging, it's a pretty simple thing in the end. If you are going to use analog plugins, let's say you're going to use analog emulation as your plugin, you have to keep in mind that they have a headroom. So if you are hitting them too hot, you're going to get distortion. And if you're hitting them too low, you're going to get a noise like we have on our tape. Many emulation has noise. Of course, you can turn it off, but analog gear has noise. So you have to hit it at a sweet spot. The sweet spot is around 0 VU. And if you want to get a hotter sound, that means more distortion, because that's what you want. If you want to get more harmonics out of your sound, you can go higher, up to 3 or even higher. And the many analog emulation are calibrated to -18 dB. So that's what you want to have. You want your 0 to be at -18 dB. You can use both VU Meter or LUFS momentary. They are quite similar. LUFS momentary is a more modern way to measure because it takes into account the levels that the ear are more sensible to, the frequencies, sorry. So it's more modern way. For instance, I'm more used to VU Meter, so I keep on using that. And the fact is that you want to have your tracks loudness set to a certain level, and forget about short peaks, because short peaks are going to be shaved off by your analog emulation or analog gear. If you only mix digital, you don't have to care about gain staging inside your session. The gain staging is all important when you are recording from outside live material. So if you're recording a keyboard, if you're recording a bass guitar, drums, or whatever, you have to make sure that you are hitting your converters, your digital interface, your analog to digital converter in your interface at the right level. Every manufacturer publishes the specs. Many are at around -12, -18, -15. The professional one can go higher at -21, and you have to set the reference in the VU meter so that the 0 level is at your manufacturer specified 0 point. Well, from a CPU perspective, LU meter it's LU meter it's more consuming than a VU meter, exactly. Quite a lot more consuming. It's not light. LU metering LU metering takes more CPU power than VU metering. But now we don't have. This is not a direct comparison because we don't have any meter here. But if I use our LU meter, if I use the LU meter here, I can make a better comparison. No, it seems it's using less CPU, funny enough. No, not there really. While playing, you see that Now, VU Meter uses 0 CPU, okay, to measure the loudness of the track, while LU Meter is using 0.2% of the CPU for the same measurement. So, of course, it uses more CPU to get a reading that is very similar. Now, from the kick, I get a lower reading in LU Meter because the ear is less sensible to the frequencies of the low kick, of the low frequencies that are so important in a kick drum. If I do the same for a snare drum, for example, use the snare up track and replace effects with a VU Meter. Now I take the two. You see that VU Meter here reports around here, which is -15, something like that. And LU Meter reports almost the same, because the snare has more content on the frequencies on which the human ear is more used to. So LU Meter reports a higher level. So Ricardo, if I use analog emulation on my DAW4 mix, the chain could be normalizer set to 0 VU, exactly, or 3, exactly. Analog emulation channel strip master, exactly like this. And keep in mind that if you use analog emulation on your master bus, you may clip your master bus. So pay attention to the level of the input. So every track, when the tracks are summed into a digital audio workstation, they cannot clip. But if you place an analog emulation over here, like I did, I have disabled the analog, but if I enable it, I can get a signal that is so hot that this emulation can clip. Now, these are VU meters input. So I am not clipping them, I know for sure, because I set -10 gain, gain. If I set 0, listen here, I'm completely clipping the plugin. So because I am summing all these tracks together, and I'm getting a real high level, and you can clearly hear the distortion from the LA2A. You hear that? Let me bypass tape, so it's even more obvious. Okay, now I'm hitting tape, I'm hitting the analog emulation of HA2A with a definitely too hot signal. You hear the distortion. Now I turn the analog off. Much clearer. That's because I'm clipping my digital bus now, because I have something that may clip. So keep that in mind if you run your tracks, after you run your tracks through your analog emulation and you sum that together. If you are using a digital analog emulation on the master bus, you may clip that. For this reason, we have these auto buttons over here that brings everything back to safety level. See, when tape was on here, we were reading -10, and now we are reading almost -13, because tape was shaving out 3 dB from all the tracks and giving us 3 dB more of a headroom for our loudness. That's what I meant before. The HoRNet FET 1176, sooner or later is coming. I need to find a unit to model, and I have yet to find that. Tony, does choice of tape versus saturation versus clipper plugins? Yeah, exactly. It depends on the kind of sound you're after. Tape is very good on drums because also increases the perceived level of high frequencies while keeping the low frequencies under control. So tape is very good on drums. But if you want a more modern sound, you can go with a plain a soft clip or even a digital clipper if you are really shaving just short transients. And if you want a more rounded sound, you can go for any kind of other distortion like the tube one or the transistor one. So it's up to you. Okay, guys, so it's been 1 hour and 15 minutes of this webinar. I thought this would be shorter, but we managed anyway to get it longer. So I hope this helped you understand better what gate staging is and why it's important, even inside a DAW. So let's hear your feedback on when the video is published. And remember that we are offering a 10% discount that you will receive by email on the normalizing plugins we have. So the VU Meter, LU Meter, and the normalizer. So you're going to get it tomorrow. It's a discount code that it's valid for, if I'm not mistaken, 1 week after the webinar. So if you want to get one of these plugins, you get this discount code to get it even cheaper. So thank you again for attending, and have a good rest of the day wherever you are. I'll have something to eat because it's 8 p.m. over here. So goodbye, everybody.